Hello everybody. First thing we're going to talk about today is our saltatory conduction, which is the propagation of action potentials along the myelinated axons from one node of Ranvier to the next. What I mean by that is what makes the conduction of the structure from one structure to the next a lot faster. So how does this happen? So here we have my beautiful drawings drawn by my brother, and here we have one unmyelinated sheath and then one myelinated. So we can see here that the current is going very slow because the axon itself, it conducts current very well, but it loses somewhat. It's not myelinated to the environment around it. But when you put these little hole things, which are not conductive, the current goes through it, doesn't lose anything, and then when it gets to the spaces in between, it gets a little boost. The word saltatory comes from the Latin saltare, or something like that, which means jump around, hop around, or move around. In this case, they're not jumping around, but they are moving from one place to another, boosted. And the whole point is to get the current from one end to the next in the least time possible. And why do we do that? Because the whole point of having the impulse from the brain to whatever point of your body, the best is because you want it to be instantaneous and as quick as possible. Because if you say, I'm gonna raise my arm, I'm gonna raise my arm, I'm gonna raise my arm, and then you raise your arm, it's not efficient. Or if you get burned and you don't feel anything, but your body's like, hey, that's burning, oh, then you move it, and that's inefficient. Versus somebody throwing you a ball and then you're reacting super quickly, and then you react to catch it. There is a disease that is suffered by many young adults today, and the question is posed to what is MS, and that is multiple sclerosis, and it's a disease that is still unidentified, like they don't know the origin of it. But essentially what it does, it slows down or sometimes interrupts the current going from one axon to the next. And how does it do that? It attacks the myelin directly. So what happens again? I'm gonna raise my arm, I'm gonna raise my arm, and then I'm gonna raise. Sometimes you will just get here because the flow of the current is so slow, or just doesn't even happen, and essentially that's what it is. What are the symptoms of this disease? They're very broad because your nervous system is very broad and it controls everything. So things like localized pain somewhere in your body, or back pain, your extremities will not move, or you will get tremors, or a lot of difficulty doing things. Another ones I have listed here are, of course, cramping. When your body's trying to move somewhere and it doesn't move, it's gotta hurt. I have fatigue, I have numbness and tingling, so like the sensation of having ants in your body. The urgency and the frequency to urinate constantly and without control. That's another one that we take for granted when we're completely healthy. I have erectile dysfunction, and then I have slurred speech and many other neurological symptoms such as vision problems, double vision, blurry vision. Like I said, the nervous system is very vast, and if you have its need to do anything and you just can't do it, then that's where the problem occurs. Things like moving, things like talking, things like seeing, or even organs that we don't control, then that's when our problem arises. And they don't know the origin or where it comes from or the cure for it. All they know is that it attacks the axon itself, slowing down the process of getting the current from one place to another. And that's it.